When we use the distance formula, we would like to be able to find the distance between any 2 points in the coordinate plane. If the 2 points form a line or a segment that is actually a vertical line, such as this guy right here, or a horizontal line, such as this guy right here, finding the distance between those 2 points is not very difficult. We can usually just count or do a simple subtraction to find out what the distances are. But if we tilt the lines a little bit, angle the lines a little bit, and we notice that we have a problem because there's no way we can figure out what this distance is. There's nothing that we can really do for either one of these lines. So what we do is we use a rule which was discovered quite a while ago by the Greeks called the Pythagorean Theorem, or the Pythagorean rule. And you may remember it. It deals with something called a right triangle. Okay? And this is a picture of a right triangle right here. And if you look at the example that we started off with, something like this, where we were trying to find the distance between this point and this point, what I do is I make a right triangle. I complete the triangle by drawing a vertical line and a horizontal line from the lower point, so that I make a right triangle, and then I can apply the Pythagorean theorem. And A and B are called legs. So this piece right here would be one of the legs. This is the second leg, and this is called the hypotenuse. And the hypotenuse is always opposite from the 90-degree angle in any right triangle. So the first thing I'm going to do to find the distance between this point and this point is to find out what the length A is, because that's pretty easy. I should be able to do that. And after that, that's the vertical distance. And then I'm going to find the length of B, the other leg. That's the horizontal distance. And then I'm going to apply the Pythagorean theorem. So I'm going to apply my A squared plus B squared equals C squared, find out what A is, find out what B is, and then calculate what C is. So in this picture, we can see visually that A is really 4, I said inches, but let's say it's 4 units. And because I just counted, okay, I was able to count. B is actually 2 units, okay. And what we're doing is we wind up with this right here. We wind up with A squared plus B squared equals C squared. A is 4, 16 plus 2 squared, 4 is 20. So I wind up with C squared is equal to 20. C squared becomes C. 20 becomes the square root of 20 when I take the square root of both sides of this equation. And I wind up with C is approximately equal to 4.47 units. And that's rounded to hundredths. That's the degree of accuracy. So what we'd like to do is create a general algebraic expression or equation that would give us the formula for the distance between 2 points. And what I'm going to do, without actually knowing what the coordinates are, I'm going to call one of the points the first point. Doesn't matter which one is the first point and which one is the second point. But notice that x2 comma y2, 2 for second, are the coordinates of the second point, and x1 comma y1 are the coordinates of the first point. Okay? And I'm still using my a squared plus b squared equals c squared. Okay? In order to find out what a is, which is this right here, okay, all I have to do is take y2 and subtract y1. That's all I need to do, okay, which is right here. In order to find out how long b is, all I really need to do is take x1 and subtract x2. You notice that I turned these around. Well, you can either use x1 subtract x2 or x2 subtract x1. It makes more sense to use the x2 subtract x1 because I'm going to be squaring that expression. Okay, and we're going to get the same answer. So since we're going to get the same answer, let's not make things confusing. So it should be y2 minus y1 squared plus x2 minus x1 squared. So we're not going to use this, even though that would give us the correct answer. Okay, equals c squared. Take the square root of each side, and I wind up with this right here, which is my formula, distance formula, where c is the distance between these 2 points, between x1, y1, and x2, y2. It doesn't matter which point is the first point and which point is the second point. So, here's the rule, okay, for the distance between 2 points. D is distance is equal to the square root of y2 minus y1, the quantity squared, plus x2 minus x1, the quantity squared. Okay, let's look at an example. We want to find the distance between 2, 8 and -3, -4. All we're going to do, and I've already written down x1, y1, and x2, y2. Let's substitute those values in the equation. And notice I get y2 minus y1 is -4 subtract, and it's very important. Be careful with your signs here. -4 take away 8, and that turns out to be, that's -12. Okay, and we're going to have to square that in a second. The other one is x2, which is -3, right? Subtract x1, which is 2. -3 subtract 2 turns out to be, -3 subtract 2 turns out to be -5. And of course I have to square that. So -12 squared is 144, -5 squared is 25. Add them together, square root of 169. Put that in my calculator, so the answer is 13. So the distance between these 2 points in the coordinate plane is 13 units. Let's take a look at a final example. Again, we want to find the distance between these 2 points. If you want to pause the video right now, you can. Give you a couple seconds to do that. And otherwise, here comes the solution. Starting off with my formula, identifying x1, y1, and x2, y2. Okay. Plugging in the values. Okay, you can go through this. You have to know sign numbers, your rules of sign numbers. Otherwise, it's really going to be impossible to get the right answer here. Anyway, the tricky part here is this is -4 subtract -8. Okay, which is really -4 plus +8, which is +4. That's how I got 4 squared here. 3 take away -2 is 5. 5 squared is 25. 16 plus 25 is 41. So I wound up with the square root of 41, which is approximately 6.4 rounded to tenths. That's the distance between these 2 points, -2, -8, and 3, -4. Okay. If you have any questions or comments, let me know. Thanks. Have a good one.